about cosmic mythology, I'm really actually talking about cosmology as a whole and the origin of the universe, and how do we know what we do know about the universe. That's really what I'm talking about, because in cosmology we are told, quite often we are told, that they're making advances, and they've made certain discoveries about the universe, about the origin of the universe, about the universe expanding, for example, starting in the Big Bang 13.7 billion years ago, and so on. But how do they really know that? What do they actually do in cosmology to arrive at those conclusions? Well, one thing is nowadays they do amass large amounts of observational data. They run simulations on large supercomputers funded by taxpayers. Thank you very much if you're paying tax. They test their models. They build mathematical models to test these simulations against. But there is no way, actually, that they can prove anything about the past. All they're doing is testing their models within these computers, right? Simulations. They cannot prove how the universe came into existence by observation. This is the main thrust here that I would like you to understand. And if I forget to change my slides, this is the problem I'm having here. You see, cosmology is really not so much about science, about philosophy. And this will become quite relevant as we go on. But first I'd like to just give you a very quick run through here. Cosmology really, you could say, started in 1929 when the astronomer Edwin Hubble, looking out with his telescope around us, and he was looking at what he called galaxies, and he saw that the galaxies all around him, in their light, the spectral lines were shifted uniformly towards the red end of the spectrum. There are a few exceptions, there's a few blue shifted ones, but largely red shifted. He interpreted that, without going into the details at the moment of what redshift is, he interpreted that to mean that the universe is expanding, right? And from this, of course, came the Hubble law, when he saw that relationship between the redshift of the light and the distance to those nearby galaxies. And this solved two big questions of the time. One was, is our galaxy the whole universe? The discovery was, of course, there's many galaxies, smaller galaxies or larger galaxies, and they seem to be receding away from us. And the other one is the universe static or expanding? And the conclusion was at the time that it's an expanding universe. Well, this was based on Einstein's general theory of relativity. Einstein had published his general theory in 1917, and at the time had also developed his own model from that. It was a static universe. And when he had heard about Hubble's discovery, he said this was essentially his biggest blunder of his career. What he had done into his equation, he had inserted what is now known as the cosmological constant in order to maintain a static universe, because he found that his equations naturally implied either the universe is expanding or collapsing. And hence he inserted it, and when Hubble made his discovery, he then removed it, saying that that was his biggest blunder. Well, then in the 1920s also, using Einstein's general theory, these two guys, Alexander Friedman and Georges Lemaitre, a Catholic priest, independently solved Einstein's field equations for a solution, for a general solution, and they got from that general solution, again, this same thing, that the universe must be expanding or collapsing, actually. And then, of course, based on Hubble's observations, they then concluded that the universe was expanding. Lemaitre said at the time, in 1931 actually, that it was like the universe began in this cosmic egg, he called it, exploding at the moment of creation. So he gave it he related a view to the Bible, as being a Catholic priest, right? Now, this I say here though, that Friedman was an atheist, Lemaitre was a Catholic priest, and I say that neither of these had an agenda to establish Genesis as real history as God said. You know, because the church, the Catholic Church, always would hold the authority to themselves, you know, over the Word of God. And so they certainly had an interest to prove or establish that they had discovered something consistent with their worldview, but not necessarily consistent with the straightforward reading of Genesis. And then Fred Hoyle, in the 1950s, on a BBC radio program, coined the phrase the Big Bang, because Fred Hoyle was a believer in the steady-state theory, which was the dominant theory up until the mid-60s. And when he was asked what did the other side believe, he said, oh, you know, something like a Big Bang. And unfortunately, the name stuck. So in Hoyle's view, of course, he was an atheist and believer in the eternal universe. And as were many of these early people, they were largely atheists. A student of Friedman was George Gamow, who in 1948 predicted that from this Big Bang there should be leftover radiation from that fireball that should be observed today, arriving at Earth at temperatures, initially he said 5 degrees Kelvin, which is only 5 degrees above absolute zero, you know, minus 260, 8 degrees below zero. Later, he revised that up to 50 degrees Kelvin. And then in 1965, Penzias and Wilson were given the Nobel Prize for the discovery of the cosmic microwave background radiation, which was then measured with a uniform background temperature of around about 3 Kelvin, 2.7 something, minus 270 degrees below zero, and in every direction of the sky. So of course this was, as many of you know, this was a surreptitious discovery. They were actually not really looking for it. They were testing that bighorn antenna behind them, and they couldn't get rid of some background hiss, and eventually they pointed that in every direction of the sky, and the hiss remained, and no matter what they did, they couldn't get rid of it. So the discovery then of the cosmic microwave background was meant to sound the death knell of the steady-state theory, because remember that had been a prediction by George Gamow back in the mid-40s. And that's how the story goes, right? So in the minds of the general public now, the Big Bang is sort of the established worldview for the origin of the universe. One other thing worth noting in the history was the idea of inflation. In 1979, Alan Guth proposed this idea that the universe very rapidly had a super expansion in the very early phase of its expansion, just soon after the Big Bang. This was to solve various problems of the Big Bang theory, including things like why do we live in a Euclidean universe, a universe that we call flat. Not flat in the sense of a pancake, but Euclidean flat in the sense of that triangles have 180 degrees. Now to a physicist that's not obvious, and by having a super rapid expansion in the early phase of the universe, you could basically smooth out all the ripples, so to speak, and have some kind of a flat universe. Well, this idea, of course, inflation has changed since those early days, but the idea is that during the early period, there was extremely rapid exponential expansion by a factor of at least 10 to the 78 in volume, driven by a negative pressure vacuum energy density, and it lasted from 10 to the minus 36 seconds after the Big Bang to something between 10 to the minus 33 and 10 to the minus 32 seconds. Now that's from Wikipedia, so you can believe it.
So when you say it expanded, like what was the initial size and what was the final size of the expanding?
So this was at 10 to the minus 33 seconds after the Big Bang to 10 to the minus 32 seconds after
that's
the
the
Big
time.
Bang. This is the time. Now, it's a good question because I haven't directly dealt with this here, but there is a complete misunderstanding by the general public about the Big Bang, what they're actually saying. And you may have heard the expression, the Big Bang began in a region the size of a grapefruit. You may have heard that expression. In fact, Lemaitre talked about a cosmic egg. Gives you an impression the universe started like this small ball, like the size of an egg. In his view, the universe started there, therefore he had God creating it as this cosmic egg. The Big Bang today, though, you'll find websites that will talk about this, that they'll very carefully insert the visible universe began in a region no larger than the size of a grapefruit. Because the universe today is considered to be flat, Euclidean geometry. For it to be Euclidean geometry and have a matter density of what's called critical, that means this perfect, uniform, flat universe, that means the universe must be infinite. Therefore, where was the Big Bang is the question? It was everywhere. How big was the Big Bang when it started? It must have been infinite in size. Must have had infinite energy density in an infinite universe to be infinite in size today. Because you cannot go from a finite dimensioned object to an infinite dimensioned object. It's impossible. Even mathematics can't do that. You see the problem? No one discusses this, but it's a serious problem. I've actually asked professional cosmologists this question, and they have no answer. It was fine in the days when they believed that the universe was not flat, was actually had a density or larger than critical, therefore it had closure, what's called closure, could be a finite size unbounded object, so finite size. So you could talk about something finite beginning in a finite size object and expanding to a finite size object, but not expanding into an infinitely sized object. This is the problem. So you've got all sorts of mathematical problems to try and solve that. So we are right at the centre of the Big Bang, if there was ever a Big Bang, and the density is all that you can talk about in answer to that question. So it must have began at infinite density to arrive at the current density it is today, which is pretty low, very low. Okay, so the question is, has the cosmic microwave background radiation and this idea of the expanding universe, has this proven the Big Bang? Well, it hasn't. It's not even close in reality. But let's continue a little bit more in history. In the 1950s, there was this kind of east-west across the Atlantic battle between two camps. And the steady staters under Hoyle, Bondi and Gold were largely in the UK, in Europe, and the Big Bangers were developing like Gamow, Ryle, Dickey and others in the Americas. But the irony is, in this kind of battle between the Big Bang and the eternal universe guys, the steady staters called these guys evangelicals. They called them evangelicals because they believed in an origin in time, yet they're actually atheists. This is kind of the strange thing about this.
Didn't Fred Hoyle refer to them as creationists?
That's the whole point. Now, part of this rivalry you'll see, Hoyle said the Big Bang is an irrational process that cannot be described in scientific terms, nor challenged by an appeal to observation. And Gamow, who was on the other side, said, I'm glad to say that it isn't necessary anymore to pour Hoyle on the trouble of cosmology. So you see what this sort of thing that went on between them across the Atlantic. So you see, even though they're actually both atheists, you see there's this, you see the worldview issues that are bound in this. It's not just those, it's not so much that view that the public have of those white men in white coats, just impassionately deciding what truth is. Far from it, in fact. And then let's discuss also the position of the Catholic Church, because that had a big bearing on the acceptance of the Big Bang. Starting in the early 1950s, Pope Pius XII, at this opening meeting of his Pontifical Academy, he declared that the Big Bang theory does not conflict with the Catholic conception of creation. And so that sort of swings the door open for the largest church organisation on the planet to accept the Big Bang as the interpretation of those early chapters, or the first chapter of Genesis. They had already previously had accepted the millions of years of the geologic column, the evolution, biological evolution. They had already accepted all that, and now this has just sort of relegated God to that just initial first cause, snap his fingers and start the Big Bang off sort of thing. A pretty weak, impotent, deistic type of God, it would seem, And then in 2011, this is now Pope Benedict, and he said that the God is now reconciled with the Big Bang. Well, the Catholics had spoken earlier in their acceptance of evolution, of this idea of theistic evolution. But really, that's kind of an oxymoron when you think about it, because it's creation by God. Biblical account just talks about that. But the evolutionists are not talking about creation by God and evolution. Evolution is the way out, to get rid of God. So it's really an oxymoron. And as is also Big Bang creation, an oxymoron. Big Bang was really developed by atheists, besides this issue of Lemaitre. But he, as I said, he had no interest in establishing the Word of God as the authority in our lives. It was the church, to him, that was more important. And we could talk about Jesuits, if you like. There's a whole lot more we could talk about that. So, but many mainstream churches, Catholics and other mainstream types, have accepted this idea that God used the Big Bang, God used evolution, and so on. And also, unfortunately, so have evangelicals accepted this notion. This article here from Reason to Believe Ministry, Dr. Hugh Ross, he said in the title of this article, "The Big Bang, the Bible taught it first." No, it didn't. You show me one verse in the Bible, or one phrase in the Bible that teaches that the Bible taught the Big Bang. It's not so. Even if you were to say that the Genesis account describes let's say Big Bang sort of evolution, we're talking broad terms here, and let's say that those days of Genesis were somehow some sort of record of the history of our universe. Forget about the days, how long they are. Let's just talk about sequence. A friend of mine calculated 37 out of sequence events that are out of sequence, that don't match. It's not even a very good story if you say it's allegorical, because they're all mixed up. They're way out of sequence. For example, in the Big Bang, the sun forms before the earth. In the biblical account, God creates the earth on day 1 and he creates the sun on day 4. Out of sequence. Well, there's 37 of those that are easy to identify. And again, this issue of the Jesuit priest, what was his real motivation? The church, supporting the church, not the Word of God, the authority in the Word of God. Hugh Ross, in his own testimony, says, and this is where this technique gets hard, he said, "I recognise that the Bible stood alone in describing God and his dealings with man from a perspective that demanded more than just the dimensions we humans experience, that is, like length, breadth and time and so on. He said further, I had proven to myself on the basis of predicted history and science that the Bible was more reliable than many of the laws of physics. My only rational option was to trust the Bible's authority, and to the same degree as I trusted the laws of physics." Do you see anything wrong with that? He actually said that at the age of 15, he concluded the Big Bang must be true and that the existence of the world demanded that there be a creator. Well, that's reasonable. But he said from the study of comparative religions, he determined that the Christian religion was the true religion. And later went on, he claims that science is the 67th book of the Bible, on the same par as the Bible. He argues that science alone can drive men to the correct understanding of our origins and hence see the necessity of a creator. I actually say it's the opposite. Science can't do that at all. One must interpret the science through the glasses that you have on. We all have worldviews. We interpret the evidence through our worldview. It's our worldview that determines how we interpret the evidence. Data alone doesn't tell us anything. It has to be inserted into a worldview to have an interpretation. So it's wrong. You can't interpret. You can't then say the evidence drives me to Scripture. That you already had a worldview. And so at 15, before he was saved, when he determined the Big Bang was the truth, he established his worldview. He did, by his own admission.
But couldn't the evidence tell you that your worldview is wrong?
No, it cannot. Evidence cannot tell you anything about your worldview. I can name you all sorts of inconsistent worldviews. People hold them despite the evidence.
Yeah, but that's just irrational.
No, it's not. It's not. You've just now set yourselves up as an authority to judge them, you see. You've just determined the rules by which you determine whether their worldview is irrational or not. That's a worldview, another worldview that you're using to interpret the same evidence.
If somebody says that the Earth is flat, then you can show that they're wrong.
Can you?
Well, maybe not. From the point of view, if a person was determined to believe that regardless, well, you can't force them otherwise. But
so now what you're talking about now is what you will accept as evidence, you see. You have a worldview, right? And so you then assume, then you pile up the evidence, and then on the weight of the evidence you say, well, that is either consistent with or not consistent with this worldview I hold. But actually, you're not really proving. You know what I'm saying? You're not proving anything. The best you can hope to do is disprove something. Yeah. Based on falsify. But in cosmology, it's not so simple. Like in an experiment in the lab, for example, I can run an experiment. I can pose a hypothesis and I can interact with my experiment. But in cosmology, I can't do that. And I'm going to talk about this some more. So we can come back to that in a minute. So, Galatians 1:9 says, though we or an angel from heaven preach any other gospel unto you than that which we have preached unto you, let him be accursed. And so what I'm saying here is the gospel that says that science is the 67th book of the Bible, that science can help you interpret the Bible, that is another gospel. That direction. That's what I'm saying. I'm saying the opposite is the actual true gospel. That the Word of God is number one in authority to interpret all things, not the reverse.
Isn't it your worldview to say that? Like, you know, that we, young Paul, they teach another gospel.
Yeah.
Well, you've got your gospel, which is your worldview, and you've got to judge the other gospel whether it's right or wrong. Isn't that much the same as people in sciences with the cosmology?
We all have worldviews.
Yeah.
I'm the same. I have a worldview.
So the Catholic view and Jehovah's Witness view are just as valid as well as your own.
Well, no, I'm not saying they're equally valid. I'm saying they all hold worldviews. I'm not saying they're all equally valid, though.
So you can't say which worldview of cosmology is right or wrong. Surely, on that basis, you can't say which gospel is right or wrong.
So, what I'm trying to, in some sense, you're right. So the drawing to the conclusion of my whole talk then, based on what we observe in the universe, We can't determine absolute truth. So I hold to only one, is that the straightforward reading of Genesis is the correct worldview. That's the worldview I hold to. Because, just what I said, science cannot prove anything else. You can insert anything you like into it. You can take any worldview and then start inserting it. And we'll see how that goes if you will bear with me for a few moments. It also says, thy word is true from the beginning, and every one of thy righteous judgments endureth forever. Is that the right one? Yeah. So in this case, I highlighted in the beginning, because I'm trying to highlight the fact that God's word is true from the beginning of creation, from the beginning of time. So what is the situation today? Well, Big Bang is a philosophy. It's a worldview, there's no question about it. It's a naturalistic worldview, there's no creator. It has only naturalistic causes, like Stephen Hawking is looking for a way to solve the problem of the first cause without a creator. In other words, first cause without a first cause, a universe that created itself from some quantum fluctuation. But of course then the problem is they go back into higher dimensional spaces. They have, 10-dimensional space with membranes in some higher space colliding in some space-time of 10 or 11 or 28 dimensions, and some Big Bang happening. They've just pushed it back, haven't they? Pushed the first cause problem backwards.
Do you want us to save the question until later, or do you mind interrupting?
Okay, go ahead.
Isn't it all this stuff about brains and the shuttlecock shape of the universe that Hawking's pushing? They're going beyond the standard Big Bang model. Like the standard Big Bang model says nothing about prior universes.
Right.
And also it says nothing about the cause of the universe.
That's right.
And it goes back to fact time and it says beyond that we don't know.
That's right. 10 to the minus 44 seconds, that's it. There's nothing. There's no physics.
But it's not necessarily atheistic or theistic from that point of view. If you stop and you say, I don't know.
What do you mean, the Big Bang itself?
Yeah.
That's the whole point though. You're now saying it's not necessary, so you're going to acquire it. But actually all of the proponents of it, with the exception of the Matra, who had God creating his cosmic egg, all of them have it as the solution to get rid of God. They're all atheists. You name me another one. Well, a couple of exceptions who are...
I've got some quotes later.
There's a couple of exceptions, but they are Big Bang believers, nevertheless, like George Ellis, people like that, for example. But the origin, the historical origin, is an atheistic origin. I'm not arguing for a genetic argument to this, I'm just giving you history of where it came from.
But the Big Bang is an explanation of what happens after blank time, isn't it? But it doesn't provide an explanation of what happened before blank time.
Yeah, but the Big Bang still has an origin. It has to have an origin. And that's why Stephen Hawking is trying to get out of that origin. He's trying to solve it without a creator. Yes?
If it is ambiguous though, if it's, in terms of what the science is there before that very minute number of time that you mentioned, if before that the basic, the model cannot explain it, then it is an agnostic rather than an atheistic or theistic solution. Yeah. And if you're to say, well, the history is that the people who discovered this model or who formulated it are atheists, that in itself is not a good reason to reject it, because medical science has been advanced by atheists all the time. We don't reject it.
You're just actually saying what I just said. I'm not arguing the genetic argument here, I'm just giving you the history from where this has come from.
Okay.
Because you have to have some history to see where the future is going. And that's still the state today. That's the state in the community.
Aren't you implying that if an atheist, like you're saying all these characters are atheists, aren't you implying therefore they have a worldview, which atheistic worldview, which then influences the way they look at things?
Absolutely, they do.
Yeah,
they do.
And I think that people who are atheists look at things like that. Some of them may become Christians as a result of it. I'm sure you could find some somewhere in the world, and somewhere in the world you could find Christians who studied this and became atheists. I think worldview has an influence, but you can change a worldview. The very fact that we're talking about the Big Bang in steady state, there are worldviews that have changed over time, and the brains and whatever goes on.
Getting under a statement, can we hear the story, please?
Okay, so let's keep going. So one more point I need to say here is in terms of the fact that these guys, even though they're all, vast majority of them are atheists, they have a religious position, nevertheless. George Smoot in 2006 won the Nobel Prize, and he said at the time, observations of the ripples, this is a small temperature variations in the cosmic microwave background, was like the handwriting of God. These are 100 billionth degree small-scale variations that he was looking at across the sky, and it's represented by the patchy, the dark and light blotches in this map, in the cosmic microwave background map. But actually the God that these guys all refer to is a God that's something like the laws of physics of the universe itself. It's a New Age God. If anything, it's like Gaiaism. Like life will just naturally arise from the universe and from the planet and this sort of thing. Now, the question must be asked, can the claims be tested that are being made about the universe? We're talking about these Big Bang claims. Can they really be tested? And what do they do to actually test their universe? Number one, they assemble mock universes. The reason they have to assemble mock universes is because there is only one universe, one that we observe. So in order to test the models, they build mathematical models and they make statistical arguments. And they compare the various models, one with another. Of course, they're just running these mock universes in some large supercomputer. And then, do they draw valid conclusions about this universe? Are they actually testing their models on the real universe? They're not. There's no way they are.
They're playing in the mud.
You see, this is like, this is a form of science that's akin to forensic science. It's very weak. You're trying to reconstruct the past, and what you're doing is you're modelling. In the present, you've got models, and you're trying to come up with a model that has outcomes after you sort of evolve it through your supercomputer, outcomes that look like what you see in the universe today. So it's extremely weak in that regard. So now this is the fundamental Achilles heel of all of this. And this is no secret. Published in 2007 in the very prestigious Science journal, 3 different cosmologists were quoted and said this: researchers have measured the temperature variations in the cosmic microwave background so precisely that the biggest uncertainty now stems from the fact that we see the microwave sky for only one Hubble volume, an uncertainty called cosmic variance. We've done the measurement, Charles Bennett says, it's not going to get any better. Now, the Hubble volume is simply the universe that we can see. That's all it is. And there's some problems with that, because as you look further and further into space, you have extinction. You have just simply due to the fact that as space, if you look at larger and larger volumes, the intensity of those photons drops off and you just can't see stuff. Just galaxies disappear from view. So if they disappear from view, how do you know they're there? You can't know they're there. That's the problem. So how do you know what the real universe actually looks like? Do you understand that? When you can't see it, or you can't see all of it. That's what he's talking about. That's the uncertainty. They call it cosmic variance. It's the unknown that you can't determine because you have nothing to compare it with. Whereas in the lab, I have an experiment and I have something that I want to compare to a reference. I simply can run an experiment and make a comparison. And I do that all the time. But in cosmology, you can't do that. And the next one is says that barrier to knowledge, some argue, is cosmology's Achilles heel. Cosmology may look like a science, but it isn't a science, says James Gunn of Princeton University, co-founder of the Sloan Survey. That's the largest survey. It's a digital sky survey looking at millions of galaxies now. Very large survey. And he says a basic tenet of science is that you can do repeatable experiments. You can't do that in cosmology. You see, it's not science in the usual sense that we understand, in that rigorous, repeatable, operational sense. It's not science in that sense at all, because we can't send in a bit of light and see what it sends out. We can't kick it and see what the response is. Now, we can do that in the lab, but we can't do it in cosmology. The goal of physics is to understand the basic dynamics of the universe, Michael Turner says. Cosmology is a little different. The goal is to reconstruct the history of the universe. Cosmology is more akin to evolutionary biology or geology, he says, in which researchers must simply accept some facts as given. So you're now being told to just accept our story. Just accept what we tell you is truth. Oh, there was that Big Bang, all this history, you know, billions of years of cosmic history. The Earth forming from some solar nebula over billions of years and cooling down. And the oceans forming, and from some volcano or some deep in the rocks or in sea spray, life just happened to evolve. Started, and then over 3.8 billion years, life evolved on Earth. He's saying exactly the same thing for the whole universe. Not just biology on Earth, the age of the solar system, but the whole universe itself, everything. You just must accept some facts as given. You cannot measure them. You cannot determine them. You're limited in your ability to know this. He's just right up front with it. See, cosmology, as I said, is a philosophy. It's not testable. Like in a lab experiment, it's actually historical science. It tries to reconstruct the past, and it's no stronger than what I've already explained. It's no stronger than this idea of trying to reconstruct some sort of record in the rock record, some geologic history of our planet by looking at the rock sequences or the alleged evolution of biological organisms over billions of years by looking at the fossil record. I mean, it's no stronger than any of that sort of stuff. It began with the presupposition of the denial of biblical authority. That's where these ideas really did begin, particularly the creation and the flood account. And this led to long-age beliefs. Geological evolution, or the long age of the planet, led to biological evolution. Charles Darwin, when he went on his cruise on the Beagle, took along Lyell's book, The Principles of Geology. Darwin was actually a geologist before he was a biologist. It was into that time frame of deep time that he inserted his ideas of biological evolution. So he needed the billions of years, well actually at the time it was only tens of millions of years they were thinking of. He needed that to have that slow, gradual change of biological organisms from microbes into microbiologists over that period of time. And similarly, cosmic evolution is naturalistic thinking for the same types of reasons. That man wants to have a solution that does not require a creator. He wants a naturalistic order, things just under the laws of physics, and time and chance is sufficient for him. And we've already talked about this, in fact, the universe itself being the creator. This is now one of the most popular views in cosmology today, which was, of course, heavily led by Stephen Hawking himself, with the idea, he said, the universe had no unique origin, no unique beginning, He was thinking in terms of like sort of a quantum world where you can have like entangled states in quantum physics because of the universe beginning in some very small quantum particle or something, and it has multiple possible histories. And we happen to sample some of them, and that's what all the confusion about is today, why we can't know how the universe began. It sounds to me like pure religion, maybe of the wrong kind. But certainly he is invoking his worldview. There's no question about it. Okay, so I like this quote from George Ellis, because he says people need to be aware that there is a range of models that could explain the observations. For instance, I can construct for you a spherically symmetrical universe with the Earth at its centre, and you cannot disprove it based on observations. You can only exclude it on philosophical grounds. In my view, there's nothing wrong with that. What I want to bring into the open, what bring into the open is the fact that we are using philosophical criteria in choosing our models, and a lot of cosmology tries to hide that. So that's the main point, that we're actually using philosophy to choose the model, not science. Because we all have been brainwashed by this notion that science is something that's sort of this scientific method, this sort of impartial arbiter of all truth. And that is far from it. It is really a philosophical worldview that determines what you are prepared to accept as evidence even, let alone how you interpret the evidence. And this is absolutely true. Even, for example, I've published some papers in Cosmology where I, for example, looked at the expanding universe, looking at high redshift supernova measurements to fit my cosmology to that data. And so I investigated, for example, how the data was first selected, because I just used somebody else's data. And I found, for example, that they would only choose supernova whose brightnesses fall into a very narrow region, brightness region. If they fell outside that region, they would reject them as candidates. But you know how they determined how bright they were to choose them? They used the cosmology they were testing to determine whether or not they would keep the data or not. Totally stacked, totally circular argument. And this is common practice. If it doesn't then fit the cosmology, that would be turfed out and say that's of the wrong class of data. This is very common practice. This is not what you hear as the scientific method, falsification, and throwing out the model. It's very, very rare to hear that type of stuff. Okay. Now, the Big Bang is based on what we call the cosmological principle. This, of course, is this grew out of the Copernican principle, the idea that the Earth is not in, well, the Copernican principle is that the Earth is not at the centre of the universe. The cosmological principle extends this, that the Earth is in no special place in the universe, and the laws of physics and basically what we see around us can be broadly interpreted or broadly believed to be the same from for any observer in the universe at the same epoch of time. So he sees, any observer would see a homogeneous universe, one that is smooth, distribution of galaxies are basically evenly and smoothly distributed through the universe. And that in every direction you look, it's isotropic, means you see the same picture in every direction. It's roughly the same distribution of galaxies. And therefore, from any vantage point in the universe, you would see essentially the same thing. But that's actually just one big assumption, because number one, you can't move to another place in the universe to test that. But there are some observations you can make to see if the universe is consistent with that. Without that assumption, the Big Bang model, we're talking about the Friedman-Lemaitre model upon which the standard Big Bang is based, utterly fails, completely does. It's essential to it. And therefore, it's believed more by blind faith than by observation. And I'll qualify that in a minute. So this is the starting assumption used to interpret all evidence. And one line of evidence that is contrary to that assumption, that flies in the face of that assumption, is named by the cosmology community the axis of evil. It's so bad, they actually give it that name. You know, that wasn't some Christian or somebody who made that up. That was them.
Wasn't it George W. who made it?
Could have, well, that was referring to our little friend in the northern part of Korea, right, and his mates. But this is a different axis. This one is in the cosmic microwave background radiation. Now, I know if you're not engineers or physicists, you may not really understand this too much, so don't worry, but just get the main thrust of it. The radiation, as we mentioned earlier, the Big Bang was really everywhere. The radiation that we see today that's coming from the Big Bang is the light that's just arriving from what was called the last scattering surface. It's like the surface of the Big Bang fireball. They should have been travelling through the universe. Remember, it's travelling uniformly in every direction, theoretically, allegedly. Therefore, the stuff that's arriving at Earth should be just like that light that just left that fireball at the point, if you go back far enough in time, to when that thing existed, right? Going back 13.7 billion years, if the universe is 13.7 billion light years to it, backwards in time. The distance, but travelling at constant speed of light, can be interpreted as time. So if it left that fireball, then it should have nothing to do with the Earth today. The Earth didn't exist. According to that theory, the Earth didn't evolve until 4.6 billion years ago, forming out of a condensing solar nebula. This radiation, however, what you can do with it, you can deconvolve it into what are called spherical harmonics. These are lower order terms. One term, for example, is known as the Doppler term, which allows you to see a hot spot behind you and a cool spot in front of you if you're moving through space. This is like tells you that the radiation is bunched up in one direction and stretched out behind you in the other because you're moving through it. That seems to make sense. That's the first term, called the dipole term. And then you have a quadrupole and an octopole term down here, and there are actually many. Now this data is taken from what was called the WMAP satellite, Cosmic Microwave Anisotropy Probe, which was to explore this effect. And they discovered in these two terms that the axis aligns with each other in the two terms. And they found the axis, the preferred axis in these terms, aligns with the plane of our solar system. And even more amazingly, it aligns with the equinoxes, which is just a projection on the sky because the Earth axis is tilted and the Sun crosses the equator twice a year when it's directly overhead, you know what I mean? So there's 2 points in the path around the Sun that trace a line through the solar system, and that gives a preferred direction in space that somehow is connected to our solar system. And yet if this was from the Big Bang, it can't have anything to do with it. Now, one satellite went up, Kobe. They first saw hints of this. They sent up WMAP, came back really strong, and they think, oh, it's artifacts, it's some processing error, it's something to do with the equipment. So the Europeans then sent up Planck. Much better equipment, much higher resolution, took 3 years of data, sent the data back. The first data they got back, these guys, Max Tegmark, they did the same analysis, and guess what? It's still there. It's in the data. It's real effect. In fact, it's not to the octopole term. That's like the third term in the expansion series. They find it all the way to the 20th harmonic term. It's in every one of these higher order expansion terms. They should have no orientation with respect to each other. It should be a random stuff. But that means there's something inconsistent with the Big Bang. The radiation is not from the Big Bang, in other words. It's somehow connected to the local physics of this part of the universe.
Doesn't that then mean it's falsifiable?
It's not falsifiable. Nevertheless, all you're doing is saying that this brings into doubt what this radiation is, that then doesn't falsify the Big Bang. How can it? Because all you have to do is say, then there's some other model, some other variant that can explain it. And that's exactly what the theorists are now trying to do. Within the framework of the Big Bang, they're now trying to find out how they can manipulate it, change it, to make it fit. But we'll talk a little bit more about that as we go. So the cosmological principle, though, says this sort of stuff shouldn't happen. It should be uniform distribution through the universe. Richard Feynman says, I suspect that the assumption of uniformity in the universe reflects a prejudice born of a sequence of overthrown, of geocentric ideas. It would be embarrassing to state, is it? Embarrassing to find, after stating that we live in an ordinary planet about an ordinary star in an ordinary galaxy, that our place in the universe is extraordinary. To avoid embarrassment, we cling to the hypothesis of uniformity. It's straight talking in a sense, because, yeah, I mean, you have to start talking about flukes and chance and probability. And in that axis of evil, that's what some people are talking about now in the scientific literature. The fluke of that happening. And people are calculating it. 1 part in 100 million or something. I don't know what the numbers are. Don't quote me on that. But they're using that word fluke, which is really quite remarkable. So here's the challenge. The challenge is this, and it's stated by astrophysicist Dr. Richard Liu from the University of Huntsville in Alabama. Anyway, he says, cosmology is not even astrophysics. First we heard it wasn't science, and now it's not even astrophysics. Or maybe it's the other way around. All the principal assumptions in the field are unverified or unverifiable in the laboratory. Because the universe offers no controlled experiment, i.e. with no independent checks, it is bound to be highly ambiguous and degenerate. And degenerate doesn't mean it's kind of sad and sick and really depraved. It means there are many multiple possible solutions to the same observation. You can pose many models that generate the same observational outcomes. So it's degenerate in that sense. There's no way by observation alone, and he says this, astronomical observations can never by themselves be used to prove beyond reasonable doubt a physical theory. This is because we live in only one universe. The indispensable control experiment is not available. And that's really where it goes to the heart of this. He says at most, no it doesn't, he said there's no way to interact and get a response from the universe, to test the theory under question, like an experimentalist might do in a laboratory experiment. Have we got the right one? No. At most, the cosmologist collects as much data as he can and uses the statistical arguments to try to show that his conclusion is likely. Hence, the promise of using the universe as a laboratory from which new incorruptible physical laws may be established without the support of laboratory experiments is preposterous. And this is really the heart of what the problem is really all about. It's very clear, in my view, what he's saying. He then comes up with what he calls his 5 unknowns. The unknown is the bit in bold. What's in red is what we actually observe. So when we look at the light from galaxies, we see the spectral line shifted toward the red end of the spectrum. And astronomers, as I've told you in the past, cosmologists and so on, have interpreted that to mean that the universe is expanding. The idea that the light is shifted because the objects or the galaxies are moving away from us. Now, we can, in the lab, we can see redshift in light. We can see this, it's called the Doppler effect, and we use it in radar when the police get you for speeding. But that's not the same thing, because cosmology is talking about the universe itself expanding, space is expanding. not the objects moving through space. The idea of expanding universe is that the galaxies are actually essentially stationary in the space, and that the universe is expanding, the space is stretching out, somehow backfilling with more space or something like that as it expands. So this is an unknown.
What's the difference between the two?
Well, the idea, if you have a particle moving through space, space is stationary, and or the particle is stationary and the space is expanding. That's the difference.
Yeah, we probably incorrectly imagine space as nothing. So,
Which it's not.
yeah,
That's right.
But if it was nothing,
Yeah.
then there'd be nothing different between the two.
No, not quite. Because if a particle like the universe, like galaxies, were expanding through space, that means there must exist space beyond those galaxies for them to expand into. Otherwise, maybe you could have a model where you have an infinite space already full of galaxies, and the galaxies expanding into that infinite space. And that's possible. You could pose such a model. But it's a different model to where you have a space of galaxies of certain density, and the space is expanding. And that's what general relativity is describing. It's not describing particles moving through space. It's describing the expansion of the space itself.
Do you have a view on what the true case is?
I have no idea. Number 2, the cosmic microwave background radiation explained as the afterglow of the Big Bang. So we observe the radiation, but this is the unknown in the dark print. Has anyone actually seen the Big Bang? Ask a Big Bang cosmologist and he will say yes. The C and B radiation, you'll say, that is the surface of the fireball, the last scattering surface. But actually, it's the radiation received here at the Earth, right? And this is where the problem comes in, because everything we observe in our experience, because we're creatures of time and space, is via the mechanism of radiation, right? It's by light. And this is the whole problem. He said 30 years ago, cosmology was largely viewed as somewhere out there between philosophy and metaphysics. You could speculate over a bunch of beers about what happened, and then you could go home because there wasn't a whole lot else to do. Now, we are moving in on a consistent picture of how the universe evolved from the earliest moment to the present. And when was it? 2005, I was at a conference in Canberra when Stephen Chu, who won the Nobel Prize in optics in '97, he was the guest of honour. This is after he won the Nobel Prize. Remember, he was Obama's energy minister in his first term, and he was speaking to a group of school children at this conference. Often at these, it was the Australian Institute of Physics Congress, and as they often do, get in a few thousand school kids to try and inspire them to do science, right? To do physics, actually. And so that's why he was speaking to them. And he said, we understand nearly all there is to know about the universe. And he went on about this for 10 minutes. And then he said, except for a few small details. What is dark energy and dark matter? Remember, he became the energy minister. I think he would know what dark energy was, wouldn't you? I would think so. But see, that's the problem. They have no idea. And dark matter, well, where did that come from? Originally formulated to solve some problems in particle physics, it started in the late 70s, this idea. And one of the dark matter particles was named the axion. This is back in the 70s. And the reason it was named axion was because it was meant to clean up some of the problems in particle physics. So it was named after a laundry detergent. And at that time, many times it's come and gone in physics, this idea of dark matter. This is nothing new about it today. Of course, they didn't find it. And it's been going on, as I said, for 40 years. Nowadays, the axion is actually considered to be a wisp and not a WIMP. A WIMP are the kind of massive particles, they're called weakly interacting massive particles. You get that? Right? That's what they're looking for in the galaxies, that type of dark matter. But axions and the ones that I look for 4 years in a lab experiment are called wisps. Weakly interacting, some people call them slim particles because they're very, very lightweight. But of course, no one has ever detected them, and certainly in the galaxy we haven't. In this room it should be 85% dark matter. All the stuff that you're made of, everything we can see and feel and interact with is the normal matter, that 4% component of the total mass energy content of the universe, which is 15% of the matter content of the universe. It's a bit...
You might get an experience of that light's a bit dodgy, then we could do
Okay, now dark energy is this new evidence that has confirmed the expansion of the universe is accelerating under the influence of a gravitationally repulsive form of energy that makes up 2/3 of the cosmos. So says Physics World. That's the description of what dark energy is meant to be. And they go on to say it is an irony of nature that the most abundant form of energy in the universe is also the most mysterious. Ooh, you know, science used to be based on, you know, experiment and observation and refutation. This is the so-called scientific method in the lab. Now, looking for dark matter, we've been doing for 30, 40, maybe even 50 years now, doing laboratory experiments to try to determine it. We haven't found any. I don't know of anyone who's posed any dark energy type experiment because it's just way out there in the cosmos. Its density is so low, it just can't be detected. It's just, you know, I could parallel this to so many things. You know, it's like, it's so slow you can't observe it. That's biological evolution. You know, dark energy the density is so low you can't observe it. So these have now become convenient constructs as part of a worldview. Okay, since the breakthrough discovery that the cosmic expansion is accelerating, a consistent picture has emerged indicating that 2/3 of the cosmos is made of dark energy, some sort of gravitationally repulsive material. But you see, this stuff is only the product of applying the theory to the observations and realizing its deficit. And therefore, you have to insert dark matter and dark energy into the model to make it fit the observations. If you were truly honest, you would turf the model completely and start again. But that is not what happens. Because what happened in 2011, they gave the Nobel Prize to the accelerating universe, essentially, to these three guys who are part of two different teams. And in that, they've essentially recognised, or are now sort of put it in stone, written it in stone almost, that dark energy is real stuff. Because they've given a Nobel Prize for it. So how can they ever go back?
Sorry, weren't they given the Nobel Prize for making the observation that the universe is accelerating?
How do you know it's accelerating?
Sorry?
How do you know it's accelerating?
Well, or for making whatever observations they made. They made observations and worked.
This is the citation for the discovery of the accelerating expansion of the universe through the observations of different supernovae. How do you know the universe is accelerating? You have to apply your model to the observations, right? It's the only way you can do it. And from the fitting of your model to the observations, you interpret an acceleration. This is the point.
With the observations, basically, redshift versus distance?
Yes, they were.
The redshift versus distance didn't meet previous expectations. I was expecting it to.
When you say previous expectations, you mean the model without dark matter and dark energy.
Yeah.
That's right. So now the framework by which you're now judging whether the universe is accelerating is the model. Just the model. That's it. Nothing more. So if I found another model that fits the same observations without an accelerating component, I'm not saying I have, but if I found one, can I then say the universe is not accelerating? Yes, I can. Because I'm interpreting it using the same data but a different model.
Yeah, I was just wondering whether they're actually given a Nobel Prize for their observations.
No, that's actually the citation there. If it was for the observations, they should have given it to Hubble. Yes?
Couldn't you come up with that model then and win a Nobel Prize?
Well, it's already locked out. This is it.
The winner's already been discovered.
Exactly. That's
Yes.
right. Actually, I do have a model of an expanding universe, and I've written a book on this. It's an expanding universe and accelerating, based on the model though, same thing, still based on the model, with no dark energy and no dark matter.
Yeah, you're different model. Right?
Different model,
Yeah.
absolutely. Not the Friedman-Lemaitre model at all, not it. Totally different. That's what I'm saying, it's still model dependent. The interpretation is based on the model.
What's the name of the book?
Starlight Time and New Physics. He's got a copy over there.
Oh, video.
Peter Sparrow was supposed to bring a box with him, but he never showed up. Don't know where he is. Lost in Adelaide somewhere. Okay, so that's what I'm trying to explain to you, that it is then the interpretation of your model, and then they've gone and inserted these components of dark energy and dark matter, fudge factors, you could call them if you like, and you still have the problem of redshift and the expansion itself, where even if we give you that, you still have these big fudge factors. Now, I say this about the Sloan Digital Sky Survey, that this data I actually use myself, but this survey is it is the largest all-sky survey, looking at now they're up to over 1 million galaxies they've now surveyed. And the idea of the survey at the moment is to support the existence of dark energy. So Sloan in America is a foundation set up by a multi-billionaire, I think after he died, if I remember the story, and he's funding this project, the funds in the foundation. So they've determined that that's absolute truth, and now they're moving on beyond that, what that truth is.
Faith-seeking understanding.
Yeah, exactly, yeah. But do they know what dark energy is? No. Dark matter? No. So really, what they're doing here is building their own Tower of Babel, in the sense that man has decided he can determine what truth is, you see. You see that? He's ignoring the fact that you have all these ludicrous contradictions, and he moves on without God to build himself his own Tower of Babel. The universe essentially, ultimately, they say, created itself, and we can prove it because we have all the, the model, the mathematics to explain it all. This is the idea. But I say, don't believe it. Far from it. Nothing like it. Because, in fact, all of the evidence for cosmological expansion itself is from the cosmos. There's no laboratory evidence to say that space is expanding at all, or has expanded, or ever expanded. Now, in my own model, I assume expanding space. But that's not the point. The point is I'm saying there's no direct laboratory evidence to prove that space expands, or ever did. How do we know the universe is not static? Because no one's out there with a big measuring rod measuring the distance from one galaxy to the other and then measuring another one. The measuring rod in this case is light. In fact, it's the spectral lines we see in the light, and then we interpret what those spectral lines mean. A friend of mine, a colleague, is coming to work with me in April this year, and he has a website where he maintains a list of all different possible mechanisms that cause redshift, and I think he's up to 50 now. So 50 different possible redshift mechanisms. So to use one, to claim one is correct, cosmological expansion, when we know there's other ones that are well proven in the laboratory, it's quite amazing, really.
Such as?
Like what?
Such as?
Other redshift mechanisms. Gravitational redshift, for example. Doppler effect that I've already mentioned. There's all sorts of scattering processes, optical scattering processes. They've got Creel is one of them, for example. They're resonant and non-resonant processes. There are many of them. Go to, it's called marmet.org, I think, marmet.org. That's where he maintains his list. Where am I up to? Okay, so Colossians 2:8, beware lest any man spoil you through philosophy and vain deceit, after the traditions of men, after the rudiments of the world, and not after Christ. So this is what man is often doing, you know. Man is, who has fallen man, sinful man, is forsaken Christ. But instead I say, like the Apostle Paul, who wrote that he was given the grace to preach among the Gentiles the unsearchable riches of Christ, it is also laid upon us, and I'm sort of inserting this, to make all men see what is the fellowship of the mystery, which from the beginning of the world has been hid in God, who created all things by Jesus Christ. I think we would all agree that that's what we need to do with our lives. And that the God of our Lord Jesus Christ, that the Father of glory might give unto you the spirit of wisdom and revelation through the knowledge of him. You know, so that we get this revelation, we get this understanding from Scripture, so that we are better Christians but better witnesses, so we can share the truth with others. And that the eyes of your understanding may be enlightened, that you may know what the hope is of his calling, and what the riches of his glorious inheritance is in the saints. And I think that is far more important than any of the science presented here. Yet the science properly interpreted only glorifies the Creator. If we start with the biblical worldview and interpret the science correctly and not do stupid things like believing in fudge factors, we can, I believe, in principle, come to a correct understanding of the universe. In principle, I say. I don't know if we're smart enough. We may not be smart enough, because we are sin-cursed, fallen creatures. However, this last year, for the first time, I heard the rumblings that the standard model should be discarded. Now, I have never in my life heard such a thing before. And at the University of Western Australia, there's a research institute called ICRA, Institute of Radio Science and Astronomy, or something like that. I've got the acronym now. Very big setup for the square kilometre array that was, you know, hoping to be won in Western Australia. They're still gearing up for what they got of it. But this was a abstract at a talk given there. So this is a leading edge institution, where he said that dark matter crisis, problems with the standard model of cosmology, and down there, here, I've underlined it, you see, he said, the LCDM model, which is the dark energy, CDM means cold dark matter, model needs to be discarded. This is, you know, I nearly fell off my chair when I read that, because it fails in so many tests. Even he mentions a couple here. There are many tests that fails. So I recommend that we hold to the Bible strongly. We hold to the worldview strongly. And I believe the biblical worldview is simply that God created as he said in 6 ordinary days, 6,000 years ago. And I have no reason to doubt it. Ecclesiastes 3:11 says he has made everything beautiful in his time. He has also set the world in their heart, so that no man can find out the work that God maketh from the beginning of creation, to the end of time. And maybe that's really a reference to us being dumb. We're not smart enough to know everything. Not necessarily that we can't know in principle, but that God has hid many things, in the sense that we are just fallen creatures with sin-cursed brains. in that sense.
My translation of that, or NIV, says that God has set eternity in the heart of men.
God has set eternity
In the heart of man, such that God might be in the end.
instead of the world.
Still a nice word.
Still doesn't change the
No,
word, does it?
I'm not saying it does, but
I was hoping to show you a few of these products. Hubble Bubble, Big Bang and Trouble, where I actually talk a lot about redshifts, the different redshift mechanisms, and that in fact, my interpretation of the cosmos is that because we are looking back in time and we are looking beyond our local vicinity, we can see way back into distances of billions of light years, that we are looking back into day 4 of creation week, where we are seeing the creative hand of God, like in Psalm 19:1, the heavens or the expanse declares the work of his hands. You know, the firmament shows the work of his hands. And that all happened on day 4 when God created the cosmos. The worldview I have and the model I've developed is totally consistent with that we are actually seeing God's handiwork in the cosmos as he created. And this one is called Dismantling the Big Bang. This looks at all the problems with the Big Bang, but it looks at it, because the subtitle suggests God's universe rediscovered. We look at it from a biblical worldview, and we find that it's very God-honouring indeed. Not the Big Bang, but the origin of the universe itself. This book here that should be released actually within a month or 2, I have a chapter in this book that I go into great detail about this very talk I've given you today. A lot of technical detail and scientific detail, not too heavy, not a lot heavier than what you've already asked and so on, but that book is coming out very soon, and toward the end of this year there's a documentary video being released by Creation Ministries, which has interviews of 14 PhD scientists across all fields in terms of looking at you see the title actually is Evolution's Achilles in plural heel, heels. Many Achilles heels of evolution in every field, yeah.
Are any of those people biologists?
Yes, they are, yeah. Some very good ones too. In fact, in biology, it's very, very powerful evidence, the problem of accumulation of defective genes in the genomes. And so if creation.com, I've published over the years many articles on creation.com, quite a few in cosmology and astrophysics in relation to the creation evolution issues. You can go there. I have a blog, easy to remember, johnhartnett.org. There are many cosmology-oriented articles there. I've tried to actually, in recent times, try to make them simpler, if possible. Tried to simplify it. It is a challenge, but so I tried to make them in smaller, bite-sized chunks to help people understand some of these ideas. That's it. That's all I have.
Thank you very much.
Yep.
It's pretty common amongst Semite people that the Earth is actually 6,000 years old, but the rest of the universe is 13.7 billion years old, and that that's correct, isn't it? No. Okay. But like you take literally that the sun, moon, and stars were created on the 4th day, and I gathered you actually made some reference to general relativity to explain the difference in time scale. So, can you actually spell us out a bit, please?
So what I would say, restating what you were saying, is what I believe is that the 6 days of Genesis, starting roughly 6,000 years ago, approximately, give or take a few 100,000, or, don't worry about it, a bit here and there. But the 6 days are literally 6 ordinary 24-hour days. yes. So that if you measured off the age of when Adam was created, 6,000 years ago, it's 6,000 years. If you measured off when the stars were all created, it's 6,000 years ago. This is the point we're making. When the earth was created 6,000 years ago, just extra day, going back in days, right? The difference is that the Bible is written from the perspective of man, the creation from earth. So it's an earth-centric view. And in that view, the clock that is used to count off time is earth clocks are used. Right? So earth clocks measure off time. And the furthest you can go back in time is roughly 6,000 years as measured by earth clocks. Right? So when you talk about the age of the universe itself, what's the assumption? Well, the implicit assumption to it from the Bible is that it's earth clocks, in other words, it's 6,000 years. But there are processes that appear to be in the universe that maybe take millions of years or hundreds of millions of years, like the rotation of a galaxy. So how do you explain that? Well, actually, we don't see a galaxy rotate. We don't. This is another redshift problem. What we see is redshift and blue shifts from the light coming from the wings of galaxies. So we have then again another situation where we have a model and we interpret that information. However, if I said that during creation day 4, for example, God created the stars of the universe, and during that day, the clocks in the cosmos tick 1 trillion or 10 trillion times faster than the clocks on Earth, then we could see many physical processes occurring in the cosmos over millions, hundreds of millions, billions of years, but all occurring on day 4 of creation week as measured by Earth clocks. And that, if you had a model that described that, that could be completely consistent with everything we observe on Earth. And the model that I have is such a model. It's a general relativistic model that describes such a process. Now, I'm not saying that that is the truth, the holy grail of truth. I'm not saying that. I'm saying it's a model. That's all I'm saying.
So, but how does that work? Does that mean that there's strong gravitational fields in some areas and not in others?
No. This model is not a gravitational time dilation model at all. It's not. Gravitational time dilation has certain limitations. We see it in our sun, we see it in massive objects, in supercompact gravitational objects, centres of galaxies, supermassive black holes. We see time dilation there, but it has its limitations in terms of redshift, for example. This effect comes from the actual acceleration of the expansion of the universe itself. And remember, I'm not saying any more than I said previously. I'm just saying it's a model that if this were true, this is what happens, and it's consistent with our local knowledge of general relativity. Our local knowledge of general relativity is experimental facts I'm talking about now, repeatable lab-tested experiments. Things like, for example, GPS clocks. Everybody here probably has a GPS receiver in their pocket, maybe. You know, it seems like we now can't live without them. But the clock that's on those satellites at 20,000 kilometre altitude is a rubidium atomic clock, and the ones that are in the base stations of all the phone base stations are local rubidium atomic clocks. The one that's in the satellite ticks faster than the one down on Earth. And this is not an effect on the clock, this is an effect on time itself. So that the two clocks, if you compare them, the satellite-based clock will tick 38 millionths of a second more per day. Not very much. real effect though that has to be corrected for. So in the algorithm for the GPS receiver that determine where you are on Earth, that is actually corrected for in the algorithm. That's actually a real relativistic effect. So that's just like a hint or a clue that these things are real effects.
But they're very small differences. You're talking about something that's got a ratio of a billion.
Sure, that's right. No, more than a billion, 10 trillion.
Yeah.
Yeah, much more.
So and you said it's something to do with stretching of space.
Yeah, that's right. It's a relativistic effect on the expansion of space and so on. Yes, like you said, this is a very small effect, but there are many, many large measured effects in relativity, like, for example, accelerating particles. We see if we accelerate particles up near the speed of light, we see time dilation on these particles of many, many, many orders of magnitude. As you approach the speed of light, the time in the frame of reference of the particle with respect to the observer, it slows right down, almost to stationary, stopping time, almost, not quite.
Doesn't your sort of proposed model...
Can you speak up, because we have to try and pick it up from the mic.
Doesn't your proposed model suffer from the exact same flaw that you're saying Big Bang cosmology does, in that it can't be tested in the lab?
Actually, I'm the one who supports the view that none of this can be tested in the lab. I mean, it's not a flaw. I'm saying it's as weak. I'm being honest about its weakness. I'm not.
It's not a scientifically better explanation. It's just one that fits better with your worldview.
I'm not. No. It's more to
change
that. Yeah, I'm not putting it forward as some solution. What I'm saying is, here is a potential solution. In fact, I know more than one. But the difference is, I don't invoke fudge factors to make my model fit. So if I needed a fudge factor, I would turf it out and start looking for another model.
Well, something I've noticed in astrophysics and cosmology is that physicists will make predictions about what they expect to see based on what they know from particle physics in the lab. And then they make observations, and those observations are confirmed or disconfirmed. I've got quite a lot of knowledge from that. I'm just wondering...
What's an example of that?
Black holes, Hawking radiation, supernovas.
Just in what respect? Prediction?
Yeah, that people will predict that these things will be found, and then we look around and look at gravity and stars, and we see that that's what we find.
You're saying black holes come from particle physics?
No, we know that that's possible from what we know about particle physics, and the prediction was based on that. And what we knew about suns and
I
stars.
have no idea what you're talking about.
Okay, well, I'll just...
Black holes come totally from the Schwarzschild solution of Einstein's field equations. Nothing to do with particle physics.
I'll get to my question then.
Okay.
If your models are based on a biblical worldview, what can they predict in the way that science does that the current models can't?
When did you stop beating your wife?
You can't answer.
No, what I'm saying is your question is ill-formed because you're actually presupposing that my model is falling into the category of what's called the scientific method.
Then it doesn't make predictions.
I can't see how it can, nor can...
Then what does it offer that Big Bang cosmology doesn't?
It also does not make predictions. You show me one prediction.
Okay.
It doesn't make predictions.
I'm
just being honest about it.
Yeah.
Sorry, in your book you said, like when we look at things like Andromeda, we're seeing them as they were 6,000 years after their creation.
Yeah.
That's right. You said that.
Yeah, that's right.
And so, yeah, I guess you inferred like one of the...
because I'm saying everything we see outside the radius of 6,000 light years, we are seeing at the creation.
Yeah,
everything,
okay.
Not just Andromeda, everything in the universe.
And therefore you don't need to invoke dark matter to explain the shape of the spirals, because like that's one of the really hard questions, like why haven't the galaxies wound up? So that's very hard to explain within the context of the Big Bang theory.
Yeah, so that's a problem for Big Bang.
But it's not a problem for you, is it?
Actually, my cosmology quite nicely explains galaxy rotation curves without
Well, I'm suggesting,
but I'm not saying
if you actually
predicted
don't have been taking pictures of Andromeda for the last 30 years, could you actually postulate a test where you could actually kind of trace the change in shape of Andromeda based on your theory?
My theory already fits the rotation curves. The rotation curves are the speeds of the gases in the disks of the spiral galaxies, right? No one's suggesting that they're not stable. I'm not saying that they're unstable. So I'm not really sure what you're getting at.
Well, if they're so young and they've kind of spiraled up so far, couldn't you see a change in the shape with time based on the absence of dark matter? Wouldn't you have something?
I don't understand your question when you say they are so young. I don't know what you mean.
Well, you said 6,000 years. You're
As
saying what we're seeing.
As measured by Earth clocks.
6,000 years.
As measured by Earth clocks, yeah.
Yeah.
They're still in their own frame of reference, would undergo the normal physics that we know today. So they would look like they're stationary because they're rotating so slowly. So in 30 years, I doubt if you could see anything different over 30 years. They're 200 million years for them to rotate. It's like taking still photographs. I mean, honestly, what difference does it make?
So I was just saying that you could actually potentially postulate something that's
You see, this whole thing, I think you're really, forgive me if I misunderstand you, but I think you are thinking in terms of lab experiments, that you have some kind of hypothesis and you can test it in the cosmos. You can't. All you can do is collect stamps. You can just gather more and more and more of the same animal and see if there's a pattern. You can't actually, maybe you could make a prediction then. You could say, well, I'm not going to find any of such and such or something like that. But it's still just stamp collecting. It's not the same thing.
there's a difference.
It's not like particle physics.
But it's not utterly hopeless. You can still do something.
Yeah, of course we can do stuff.
I guess you were talking about historical
Science, yeah.
right? And I think that's probably a pretty good reference. Sometimes in this group we discuss history, in human history, and you can look at all the evidence and you can say, well, look, I believe that Julius Caesar existed, and here's my evidence. You can't prove it beyond all doubt. You can prove it perhaps beyond reasonable doubt as far as you're concerned. So, and so when you're talking about this sort of historical science, you're looking at the evidence much like a historian looks at the evidence.
Yeah, and it's weak
not
in
like
that. It's weak in that sense.
Not like an industrial chemist looks at the evidence.
Which is now the scientific method when you go to repeatable science. This is not the same thing. It's quite separate. And in the case of Julius Caesar, you then rely on eyewitness accounts that knew him, and their writings. So it's a different matter again.
So it's even more vague.
Much more vague.
It's even more vague than trying to figure out what happened in history.
But it's not like the same thing where you might, in particle physics, for example, have a model of a theory, right, about something in particle physics, and you say, if my theory is right, if I hit it with this radiation, I'm going to get this outcome. In cosmology, there's nothing you can do. You're not interacting with the universe. There's no real prediction you can make.
Observations.
Exactly. So when they said, for example, that they predicted the hydrogen-helium ratio from modelling the Big Bang, actually that wasn't true at all. They already knew what the ratio was when they started doing the calculations. And the last thing they're going to do is publish anything but actually what is observed. That would be stupid, And then,
Isn't that assuming that they're actually deceitful?
who?
those people that have published that.
I'm not saying anyone's
Well,
deceitful.
you are. You're implying that they're deceitful.
No, I'm saying that they knew the result before they started the calculations. So why would you publish something contrary to the observation?
Correct. So there's probably a million other people who have done the same observations.
But it's not a prediction, though.
No, we're not arguing that.
Well, what I'm trying to explain is that in cosmology there are no predictions. You can't really make a prediction in the sense of what you're talking about, which is the rigorous, repeatable, operational science. Not in that sense. The only sense you might make a prediction is based on statistical arguments, that you expect to see more or less of something, or you assemble a large body of evidence and you look for some sort of statistical significance, from this body of evidence. But you can't interact in that sense.
No, we were not arguing. But you can observe over time, like you say, it's historical. Our knowledge, I won't use the word understanding, our knowledge of what we're seeing is growing and growing. And I don't think anybody, my perception of science is that they're trying to observe and find the truth in their own worldview, perhaps. But there's certain indisputable observations that are made.
I'm not, if I gave any impression at all that I'm thinking, that I'm saying that an atheist astronomer or cosmologist is trying to, sort of be deceitful or, sort of load things his way by using dark matter or dark energy, that was not my intention whatsoever. They do it.
Did come across that way?
Well, they do it within their worldview.
I'm a Christian, by the way.
I'm not suggesting anything else. But what I'm saying is that it's totally consistent with their worldview, and they are creatures of their worldview. They are.
Jeremy, you had a question early on.
Yes, I've also read Russell Humphrey's early book, Starlight and Time, and I've heard that he's changing his views on something. Is that true?
Yes, he published a new model in 2008, so 5 years ago.
Is he doing a book of it, or is
Yeah, I've heard that he's writing a new book.
Right.
Yeah. But actually, it's all published already in 2 papers.
Oh, so you didn't write that? I thought
Which one?
Starlight and Time.
No, that's Russ Humphreys.
He wrote this one, Starlight, Time and New Physics.
Ah, see, now I got them confused.
John,
Yeah.
I'd like to ask you, your theory, and others too, of cosmological relativity
Yeah.
is fascinating to me, and I'm not a slouch with mathematics, but I still find what I have encountered of it a bit challenging, and I'd like to get on top of it better. Have you got any groups together where you teach the subject?
No. I've published about 6 or 7 papers in that area,
Yes.
and theorists are not very interested in it. It's a case of ignoring it. Very difficult to publish. The last effort was in around about 2000. Well, actually, I published one last year, but the main effort was a book. I really edited the book after Carmeli died in 2006.
Yeah.
His wife called me and asked me to help finish off this book that's published by World Scientific, and that has probably the best collection of papers as chapters in a book that you can buy. That has pretty well everything in there in one large book. Basically around that time, I sort of changed my focus because very hard to publish because it's sort of shunned and ignored largely.
My own view is that Einstein's general relativity, in many ways, you can see equations which, in local situations and small velocities and so on, they simplify to being just Newton's laws.
Yeah.
And Carnelian has extended that so that in local situations it just simplifies to Einstein's laws.
Yeah.
And to me that's a very exciting revelation. That
it's not without
these higher truths just simplify to the original information of Newton anyway.
Yeah. It's not totally without its problems because it's still not fully developed. Carmeli never solved the full general 5-dimensional problem of the universe. Never did that. And so yeah, I mean, there's still work to be done. There's actually a paper that's going to be published very soon by a guy called Fermin Oliveira, who has a very, very nice solution using Carmelian cosmology. And it's going to be published in the International Journal of Theoretical Physics. I know because I'm one of the reviewers. And so that's worth a read, I think.
So my related question was, are there people who are excited about this new thing?
There's a few, but they're very few.
Yeah.
That's the problem. It is a big challenge to the standard model, and that's one of the main reasons I think it's shut down. For example, years ago, I tried to publish a paper. I submitted it to the Astrophysical Journal, and it was fitting to high redshift supernova measurements using this new cosmology. And it was rejected because the reviewer said, if you can answer the question why we live in the Euclidean universe, I'll accept your paper. And my paper at the time had no discussion whatsoever on that question. I had no idea the answer to that question. But it wasn't in the paper either. No hint of it anywhere. But the reviewer rejected it because I couldn't answer that question. So don't tell me that they're unbiased. They're totally biased. And it's very hard to pursue something that is not within the sort of mainstream, if you know what I mean.
Indeed.
And you have to find time, part-time to do it. So some of my latest work, I did publish a paper early last year where it's a cosmology, it's Carmelian cosmology. I don't know if you guys know any of this, that's what I alluded to in the book. And that's what Starlight Time and the New Physics is based on. This cosmology of Moshe Carmeli from Ben Gurion University in Israel. And I basically borrowed it and applied creationist boundary conditions using his cosmology. Anyway, I published a paper in the International Journal of Theoretical Physics this year that has a model, there again, this is just a model of a galactocentric universe, that our galaxy at the centre of the universe, and that that model then produces exactly the same outcomes as a unbounded or a finite, any of the unbounded models. So that means, in the upshot, it means you could have a finite bounded universe with our galaxy smack at the centre, and in that cosmology you would fit to the high redshift supernova measurements just like you would in an unbounded cosmology of the standard model.
without the fudge factors.
Without dark matter.
Dark energy and dark matter.
And you still have a galactocentric universe. A universe with a centre and with an edge. And yet you don't need those fudge factors. That is published. Remarkably, it's published.
What email is that?
International Journal of Theoretical Physics. If you go to my blog, johnhartnett.org, I've written a little article about it and linked it off there, and I think I even maybe made a PDF of it so you can download it, because you may not get access to it otherwise. But I'm not sure if it was even legal.
It's past 9, so don't feel embarrassed if you want to leave. We are able to go on, so if there are some other questions?
The expulsion of quasars from the galaxies.
Yeah.
What do you think that shows?
I think it's a very good idea, and that's ongoing research right now. Hoyle died just around Christmas.
Can you explain the question? I'm
Yeah,
sure a lot of
okay.
people didn't understand the question.
Over the decades, many years, Hoyle came up with an alternative hypothesis that galaxies are born from the hearts of active galaxies. They're like ejected from hearts of galaxies. You have galaxies ejecting galaxies, while AGNs ejecting quasars, and that over time they form into normal galaxies, spiral galaxies, and so on. He started that back decades and decades ago, soon after he was kicked out of Mount Wilson and Palomar back in the 50s, I think it was. He went to Germany, where is it in Germany? To Max Planck Institute in Germany. And he's written several books on it, Seeing Red, for example, the idea, going through this idea. Now, he's not a Christian. Well, he's a believer now, but he's not a Christian because he just died. He was an atheist. In fact, he was a believer in Gaiaism, interestingly enough. And so it fits very well to a creation scenario, though. If you could imagine on day 4 of creation week, God creates the stars and galaxies, and he actually creates them from the active parts of other galaxies. That fits in very well. A friend of mine, Gianluca Gemelli, a theoretical physicist in Italy, he calculated using the Carmelian cosmology, if you rapidly expand it based on hydrodynamic considerations, which just looks at energy content of the universe, that as you expand that universe, you actually have to create matter out of the vacuum. Because space is not nothing. Space is something. It contains enormous amount of energy. And then by stretching that space out, you actually create matter. Energy condenses into matter. And so I see in a creation scenario no problem with that happening over day 4, which measured by cosmic clocks takes billions of years. You know, hundreds of millions of years for individual galaxies, but billions of years overall. And that fits in very well. So in recent times, I've been working with Chris Fulton, an atheist, and Holton Arp, an atheist, and we have a paper submitted to the Astrophysical Journal together, and unfortunately he died, but where we're working on this scenario, and Chris and me and Arp previously had looked at large-scale surveys of galaxies and quasars, where we found a statistical correlation of quasars being physically associated with parent galaxies. And that was published in 2012 in the Astrophysical Journal, which is the leading astrophysics journal in the world, and that's published now. Took 6 years to publish it, because fighting with reviewers after reviewers after reviewers who were Big Bang believers and just did not like it, but in the end they just could not refute it in the end, because the analysis was robust, statistical analysis, you see. It's just stamp collecting, just by piling it up. And so they say, okay, there's an anomaly here, and so the interpretation then is applied to that anomaly. And we're continuing with that now. We have a new paper doing similar stuff, but with some new survey data, and we're trying that out as well. But that seems to suggest that not only are the redshifts from quasars different to the redshift from galaxies, that they're quantized. They come in discrete numbers, certain discrete sort of numbers, and so when they get ejected from galaxies, they have specific redshifts that change over time, sort of like drop down in redshift. But again, it's a model, applying it to this large amount of stamps that we've been collecting. Or Sloan survey, thankfully, now up to 1 million galaxies, very useful stuff, and it's all free, because it's either funded by the US taxpayer or by the Sloan Foundation. There's a couple of others as well that are doing it, and it's very, very nice for us at this time. And also I'm looking at large galaxy surveys as well. I'm looking at the Sloan data, 1 million galaxies, with the Institute of Creation Research have given us, or involved them. They have 2 of their researchers, Jason Lyle, who's an astrophysicist, and Frank Hebert, and my former student at UWA, are working on the Sloan survey and looking at the quantized or the preferred redshifts of galaxies around our local space, and seems to suggest, preliminary anyway, published 2 papers on it already, that suggest that we live in a galactocentric universe where the galaxies lie on shelves around us. There's their preferred redshift spacings of around about 100 million light years, 100 million and 250 million light year redshift spacings. And at the centre of that structure is roughly about 100 million light years from us. So that's like a supergalactic structure of hundreds of millions of galaxies, like an onion, you know, the rings of an onion. And they're all concentric on one point in space. And now I'm trying to prove that that point in space is not at the observer. Because if it's at the observer, I can't prove that it's not just some redshift space effect, like due to time, due to expansion effects. But if it's not at the observer, that proves that it's a real space effect, and it is a real super galactic structure, like supercluster.
So where do you think that centre is?
It's about 100 million light years from here.
So what's 100 million light years from here that would be so special?
Our galaxy, in other words.
No, 100 million light years from our galaxy.
Oh, from it.
So this is just looking at the
That's
data.
some distance. I mean, that's not the Earth at the centre, then, is it?
Absolutely not.
Mm.
But on the cosmological scale, that's still a galactocentric universe.
It's not very far at all, really.
Not far on the cosmological.
Yeah, but it's not. So what's there? Like, we're here. What's there?
Who knows? Maybe God's just sitting there in his armchair. I don't know.
To suggest that the universe is in fact finite and that we might be somewhere near the centre of it is absolutely a ridiculous, absurd statement to most people.
Yeah, that's true. That's right.
But
But
that's
it's-
philosophy, though.
But remember, it's an interpretation of this data. That's the thing. It's an interpretation, and it's an interpretation that the standard community would not even consider. They wouldn't.
Yeah, and if you think it's hard for you to defend that sort of worldview, imagine what it's like for, average Christians who don't,
Yeah.
who can't talk science like you can.
But part of the problem is that people don't understand what the issues are, and the issues are they still think about cosmology as like the scientific method applies to it, but it doesn't. It's just like you were saying earlier about it being historical science. That's where it has to be. It has to be in the forensic science camp. And unfortunately, people naturally apply this kind of scientific method to it when it just can't. These guys were cosmologists who said that it's not even science, because they mean in that sense.
I believe some books have just turned up.
Peter. We're wondering if you were not
And so would you like to explain what is here?
I'm not sure. Have you brought those books?
We have 2 DVDs for you.
Hubble Bubble, Big Bang and
Hubble
Trouble.
Bubble.
Okay, and
And we've got
Starlight
Starlight
Time
Time
and the New
New
Physics.
Physics.
So there's a DVD on this. I use a lot of animations to try and explain it.
Yeah,
And
book.
Starlight Time and the New Physics and Dismantling the Big Bang.
Can I ask how this
And we have Refuting Evolution.
how's this different to the new version?
Very little difference. There's a couple of small differences. In one appendix, some of the early work on the large-scale structure, I had done more work, and so I had to eliminate some stuff. The science changed. The science changed, as naturally these things do. More observations, more stamps, and things weren't as I thought they were. Statistics changed. That's all that happened. And the other aspect of it, instead of saying that the clocks in the cosmos tick much faster than clocks on Earth, in that version I said clocks on Earth tick much slower than clocks in the cosmos. But actually it's wrong. It's really the other way around. You might say, well, isn't that the same thing? It is essentially, but it's slightly different. Just slightly different. Because you have to view it in terms of, okay, when the clocks stop ticking faster, which clocks? In other words, during creation day 4, Earth clocks are ticking a certain rate, and clocks in the cosmos tick much faster, and then after the end of day 4, clocks in the cosmos simply started ticking at the same rate as Earth clocks. And so with respect to what the state of the clocks are today, that's the reason. But the results are the same.
Just ask one further question. Do you find that if this model didn't have the obvious implication that, God is very obviously behind it, it would be more obviously accepted by the community as a
No,
child?
I don't think so. Carmeli faced the problems long before I came along.
It's just frustrating for me because I find that any view, I'm a young mathematician, but I find that if people were really open, they would be open to any view, but they obviously don't because it's where you've got that.
I don't believe that's the case at all. I believe people already form their views.
Yeah, I know. Yeah.
And,
should be as exciting view as possible.
I think oftentimes the problem with cosmology is, and I go back to this again, is that you can't ask the same questions in the same way. You have to ask the right question But actually, in all the news reports and everything, they talk about it just like they do in any old experiment in the lab, and that's just not true. And that's the problem. And that's actually the only thing I really tried to get over to you tonight. That if you start with that idea that you're going to test some kind of a model on the cosmos, then you will fail. You'll end up inserting things into that model just to maintain, like insert dark matter and dark energy, because you can't believe that there's any other possibility. It's like assuming the Big Bang is true first, and then everything else flows from that. But it doesn't work like that. So it's a totally different thing. Yeah.
Right, last question.
It's probably a little bit elementary, a bit more theological than scientific. I hold to a young man position as well. One of the key phrases we use is a literal 24-hour day, based on the Hebrew word yom followed by the numeric qualifier. How do we explain a 24-hour period from Earth-box or the human point of view prior to day 4? And how do we explain evening and a morning?
If there's no sun, do you mean? Well, if you have the presupposition that those are 24-hour days, that Yom does mean 24 hours, and the first one actually was 1 day, which is an ordinal number, right, for day 1. The other ones are cardinal numbers, 2nd, 3rd, 4th, 5th. So it seemed like God deliberately said for the first one was 1 day. The rest of them, it's not saying it like that. It's saying 2nd day, evening 1, 3rd day, evening and 1. So it's then counting them off. So it doesn't depend on the sun. It doesn't depend on the sun being in existence to determine the length of a day. It just depends on the word of God, what God said. Some creationists talk about there being a light, as God said there was light. I don't really think it's so essential, because there was light can simply mean God created the energy of the universe, because light means all radiation, doesn't it? All parts of the spectrum. So I don't think it depends on that. But certainly I do believe the Earth had to be rotating. The natural form of a body of water in space, due to things like angular momentum and things like that, you would naturally think if it has gravity, it's gravitational energy, it would collapse, and if it collapses, it spins. So you would have a rotating body. But of course, during the first 6 days of creation, God is creating. The laws of physics aren't always totally as they are today. They can't be, because we don't make energy and matter out of nothing. Ex nihilo, we don't do that. So for me, I don't see any problem with it, because if you hold to that worldview, then it's fine. God can sustain the plants from day 3 to day 4 without the sun. And besides that, 1 day wouldn't have hurt them too much anyway with it. And it's the same sort of argument, though, really. Yeah.
Isn't it, instead of getting into all that stuff, isn't it just easier to assume that the people who wrote that part created it as just a myth like every other religion, and they didn't know what they were talking about when it came to cosmology?
Okay, that's fine if that's the position a person wishes to take, but my view, this is the view I hold to, is that the Word of God is the authority in all these questions, that you can trust it.
And that's what you base your models on?
Yes, quite frank. The Carmelian stuff came before me. I didn't invent that. I worked on his cosmology for quite a few years, and then one day I decided to apply a creationist boundary conditions, the creationist scenario to it, if you like. So I took an existing cosmology and applied it to that.
It just seems like you've admitted that if you have that worldview, then you can't allow yourself to find evidence that refutes it, because you just find a way to work around it to make your worldview true, which is what you've done by coming up with those models.
What I will agree to you on this is that I hold that my worldview is true, but I don't hold very strongly to the models. If I find the models fail, I'll turf them. In fact, I'm the guy that examines the model to try to find problems with it. And right now, you know what we're working on right now? A belief that the universe is static. So if I find the evidence is strong for a static universe, hey, I'm sorry, starlight and time is not much good anymore.
But if it looks like everything's moving away from us and it's all 13.7 billion years old, but your worldview is at 6,000 years old, you can't accept that evidence that it's 13.7 billion years old. So you've got to find a way to make it 6,000 years old.
No.
Do you ever do anything like that when you're examining evidence?
How do you know?
Something like? Well, I get the feeling that you're not asking this question from a neutral position yourself.
I mean, how do you know it's 13.7 billion years old? What makes that
Because
different?
it's scientific consensus.
Ah, phlogiston. Who knows about phlogiston? P-H-L-O-G-I-S-T-O-N. Phlogiston. You know about phlogiston? 100 years it was the scientific consensus. 100 years. Every scientist in the world. And what did it turn out to be? Total lie.
There's a bigger story than that too. Galen had this theory about humours that lead to our health.
About what? Humours.
And for thousands of years, people believed that you could siphon off people's blood and make them healthier.
Yeah.
And they were doing it only 100 years ago still.
Yeah. In fact, didn't George Washington die from it?
Yeah.
I think that's true. They bled him to death.
They bled him to make him healthy.
I think there are many examples. I think Jonathan Safdie told me one in chemistry. Well, actually, phlogiston's close to that, but this is a different one in some chemical reaction which I had never heard of. Some idea that had been around for a long time too, and I'm not into chemistry that much. But apparently, this type of thing is not uncommon. That they call these things paradigm shifts. And the way a paradigm shift occurs is when some young upstarts, and phlogiston's a good example, like Lavoisier and people like that, Thomas Dalton, quantitative chemistry and stuff started to be developed. It's the young guys that lead the charge into the paradigm shift. The old guys, in the phlogiston case, for example, went to their graves believing in phlogiston, even though the whole thing flipped over in a matter of about 10 years or so. The old guys never accepted it.
That's before they discovered atoms, right?
That's right. This is part of that slow process. It came from chemistry first, and then as things got, what is the smallest thing you can divide something into, and that's where eventually you get down to atoms and so on.